Okay, as shown in the figure, the charge Q is midway between the two other charges. If Q is negative 7.5 nanocoulomb, what must be the charge Q1 so that the charge Q2 remains stationary as Q and Q1 are held in place? Okay, so you see here he said Q and Q1, they are held in place, means they are fixed at their position. Okay, they are fixed at their position. Okay, fixed at the position. All right, I don't need to draw that one. Okay, so what must be the charge Q1? So the question actually asks for what? Asks for charge Q1. He want what is the charge Q1? So what is Q? What is what we want to find charge Q1? Okay, we want to find charge Q1. So Q is given. Q is a negative charge. Q is a negative charge is given. Okay, maybe I write it down over here. This Q is negative 7. Let's draw it over here. It's negative 7.5 nanocoulomb. Put it. Okay. Okay, I got the charge Q. It's midway, 10 cm, 10 cm. Need to change to meter later on. Okay. What so that the charge Q2 remains stationary and Q and Q1 are held in place. So what is Q1 value? Do I have the Q1 value? What is the charge Q1? Oh, I need to find Q1. Do I have the Q2? Do I have the Q2? I don't know. Yeah, Q2 I don't know what charge, but I have the big Q. Yeah, I don't have this. I don't have Q2. But never mind. I don't think it's important. Okay, I don't think this Q is important. Q2 is important. Okay, so what is the charge Q1? So we want to find this charge. Yeah, we want to find this. What is this? Yeah, this one Q2 we also don't know. Okay, so he say important is Q2 remains stationary. Q2 remains stationary. What does it mean Q2 remains stationary? It means it is equilibrium. It means it is in equilibrium. That means that there's no resultant force on the Q2. Resultant force equal to 0. So actually our focus, our target is on Q2. Understand? This is our target. Because we focus the equilibrium on Q2. This is our target. Although we want to find charge 1, but Q2 is actually our target. We need to focus on him. Okay, on it. Yeah, on this Q2. We need to focus on this. Yeah, this is our target. Put it as okay. Now, this is our Q2 must be equilibrium. So we need to draw the force on Q2. Yeah. So to see the Q2 is in equilibrium, remains stationary. That means you must draw forces. Draw the forces acting on Q2 to show that it is equilibrium. To show that the total force on Q2 is 0. So what are the forces acting on Q2? What are the forces acting on Q2? So we need to see the relationship between Q1 and Q2. We also need to see the relationship between Q and the big Q and the Q2. Okay, the relationship between Q and Q1 not important. We can disregard it. Okay, we need to see the relationship of whatever charge on Q2. Yeah, draw all the forces. Draw all the forces only on Q2. On Q2, draw the forces on Q2 only. Understand? On Q2 only. Because it is our target, we want to see it in equilibrium. Okay, and then once we once in the process, we can find the charge Q1. Believe me. Yeah. in the end, this charge Q2 will be cancelled in the equations. That one also believe me. Yeah, let's do and see. Okay. What must be the charge Q1? Okay, so you see this Q2, it didn't mention it is positive or negative charge. Okay, let's put it as a positive charge. Let's say it is a positive charge. Let's say lah, yeah. Let's say we don't know it is what charge, but let's say Q2 is a positive charge. Yeah, let's say Q2 is a positive charge. So what are the forces acting on Q2? What are the forces acting on Q2 by Q1? Okay, don't see. Q1 we don't know what charge. Yeah, is it positive or negative? We also don't know. Let's look at between Q2 and Q. Q is a negative charge. Q is a negative charge, but Q2 is a positive charge. So they should attract each other. They should attract each other. So I can say this. Put this as maybe put this as okay. I just put like this. This one is A. This one is B lah. Understand? Charge A. So force by big Q is, I can say, force by big Q is force A lah. Okay, we know that positive, negative, opposite sign they attract, isn't it? Opposite charge they attract. So between Q and Q2, attractive force. So FA is towards the negative charge. So FA to the left. Okay, and now I want the Q2 to be stationary. So if I want Q2 to be stationary, so what must be the charge on Q1 so that Q2 will be stationary? What must be the sign? What must be the sign on Q1 so that Q2 will be stationary? Equilibrium. I cannot put this Q1 as negative. I cannot put it as negative. Why? Why cannot negative? Because if negative, it also positive and negative. Q2 is positive, Q1 negative. So they attract some more. You see that? FB will be to the left also. FB will be to the left towards Q1 also. So this FA and FB cannot cancel each other, but they add up each other. So it cannot be equilibrium on Q2. Impossible to be equilibrium on Q2. The Q2 cannot be stationary because got resultant force. Because FA and FB, they're in the same direction, they add up, got resultant force. They cannot cancel each other. So Q1 cannot be negative. It must be positive. It must be positive. Understand? It must be positive. Why must be positive? Why must be positive? Why must be positive? Why Q1 must be positive? Because positive, Q1 positive, Q2 positive, repel. Same sign, repel. Q1 and Q2, same sign, so they repel. So force from B is to the right. Force from charge B is to the right. The force from charge B is to the right. So force FB to the right, and just now FA to the left. So this one they can cancel each other. This one they can cancel each other. Understand? They can cancel each other. So that the resultant force, I can say FB is positive. I can put the direction going to the right. Yeah. Still remember the direction. This one. Yeah. About the direction. Hold on a second. Okay, direction to the right is positive, direction to the left negative, direction upward positive, direction downward negative. So about force or electric field, we're talking about direction, right? Direction. So talking about direction, so we should put the positive negative sign for direction. So when we talk about the resultant force on the Q2, resultant force on Q2, it is all right. Okay, so you see that because going to the right, the force is positive. Going to the left, force is negative. So we can say FB is positive, FA is negative. So I can say that FB is positive, FA is negative. The positive negative sign is to show the direction of the force. So equal to 0. This is what we call equilibrium. Equilibrium. Okay, and at last you will find that FB equal to FA. See that? Equilibrium. The force to the right equal to force to the left. Force to the right equal to force to the left. That's equilibrium. Okay, total force equal to 0. Okay, so okay, so maybe some of you may wonder, what if this Q2 is a negative charge? What if Q2 is a negative charge? What if Q2 is a negative charge? So okay, if you wonder like that way, let me show you. Maybe I draw the other place. Maybe okay, so this is Q, and then this is Q2. This is Q1. Okay, so this is a negative. This is a, let's say this is a negative charge. Okay, negative charge. So okay, we put this as just now. This one is A, this one is B. All right, if this Q2 is a negative charge, what will happen? So what will happen is this FA should negative, this negative repel, isn't it? Negative repel. So FA is to the right. And how about Q1? Q1 should be what charge? Can it be positive? Can it be or can it be negative? Can it be negative? Can it be negative? If negative, negative also repel. Also repel. Also repel. So the FB also going to the right. So it cannot be. It cannot be. Yeah. So this this FB, this what I can say, if this Q2 is a negative, okay, this Q1 if also negative, so negative charge and negative charge repel, right? Repel. So FB to the right. So the total force cannot be 0. The total force cannot be 0 because but resultant force FA and FB not cancel each other, but they in the same direction. They add up each other. So got resultant force. So Q2 is not in equilibrium. Understand? So no matter what, Q1 must be positive. No matter what, Q1 must be positive, even though Q2 is negative. Okay? No matter Q2 is positive or Q2 is negative, the Q1 must be always positive. Q1 must be always positive. This one Q1 must be positive, even though Q2 is negative. You know why? Because Q1, if Q1 positive, Q2 negative, then Q positive negative attract each other. So then FB is over here. You see that? FB over here, so they can cancel each other. Then only can cancel each other. Then only the resultant force equal to 0. You see that? This is the case if the Q2 is a negative charge. Yeah, the Q1 still positive. If Q2 is a positive charge, Q1 also positive. If Q2 is a positive charge, Q1 also positive. If Q2 is a negative charge, Q1 also positive. So no matter Q2 positive or Q2 negative, not important, because the question asks about Q1. Q1, and no matter Q2 is positive or negative, Q1 is always positive. So the Q1 is always positive. So the Q1 answer must be always positive, cannot be negative. That's why you can see all these are positive answer. You see? That's how we know. Even though it didn't mention what charge is it positive charge or negative charge, it didn't mention, but we still can find out. Yeah, if you are smart enough. Okay. So now let's look back to this one. So FB, FA equal each other, so they cancel each other. Okay, so now let's calculate. We want to find the Q1. So how to find Q1? So force, the formula for force is, electrostatic force is KQQ over R square, isn't it? KQQ over R square. KQQ over R square. So that means okay, let's look at B. FB is between Q2. You see that? FB is between Q2 and Q1. Okay, Q2 and Q1. So okay, the force FB is between Q2 and Q1. Positive charge, repel, isn't it? Repel. So FB is between Q1 and Q2. Yeah. So FB is K Q1 Q2 over R12 square. Okay. Or we can okay lah. And then how about FA? FA is between what? Is between FA is between big Q and Q2. Big Q and Q2. FA is between big Q and Q2. So let's write it down. K big Q and Q2, isn't it? Between big Q and Q2 over how to write? With just RA lah. RA. Okay. So let's continue. Put this in somewhere else. Okay. So as you can see from here, what value of Q2? Yeah, the Q2 value is not provided, right? Never mind, because it's cancelled in over here. See, Q2 is already cancelled. We don't need the value of Q2. We don't need the value of Q2 charge. We don't need. It's already cancelled. And then the K also cancelled. And then what else? Now you just need to find Q1. You need to put the distance R12, and then RA. Okay, so let's find out. So Q1, R12 is 10 cm plus 10 cm, so it's 20 cm. 20 cm. Okay, R12 is 20 cm, so 20 cm divided by 100 is 0.2 meter. I need to change to meter. 0.2 meter square. Okay, between 1 and 2 is 10 cm plus 10 cm, so it's 20 cm. 20 cm is 0.2 meter. Okay, and then equal to the big Q. Big Q is negative 7.5 nanocoulomb. Okay, I maintain as nanocoulomb. Okay, Q. Okay, this one, the force is a vector, isn't it? Force is a vector. So for the charge, Q, I know big Q is a negative charge. Okay, but charge, ignore the negative sign. I told you already last time. Talking about vector, we want to find magnitude of any force. We ignore the sign on the charge. We only put sign on direction. Understand? Only put positive, negative sign on direction. But for the magnitude of the vector, like force or electric field, we ignore the sign on the charge. So this charge, I know big Q is a negative charge, but we ignore the negative sign. Okay? So don't put the negative sign. So don't put a negative sign. You just put 7.5 positive value. 7.5 nanocoulomb. Okay, I maintain as nanocoulomb because in the answer is all nanocoulomb. So I don't need to change to the nanocoulomb. And then this RA is 10 cm lah. RA means from Q to Q2. Q to Q2 is only 10 cm. 10 cm is 0.1 meter. Divide by 100. So 0.1 meter. I can find my Q1. So what's my Q1? Let's calculate and see. So 7.5 divide by 0.1 square. 7.5 divided by 0.1 square. And then multiply by 0.2 square. Multiply by 0.2 square. What is the answer? Okay, 30 nanocoulomb. That's the answer. 30 nanocoulomb. 30 nanocoulomb. Is that correct? Yes, that's the answer. 30 nanocoulomb. Okay. So that's all for this equilibrium questions. So I hope you understand. Okay, bye.